Wow, that's such a unique.
Kramer,
What?
when's this test?
I told you yesterday when this test
No,
came.
you did not.
Yes, I did.
You did not tell me.
What did you
You
say?
said Thursday.
Yeah. She wrote her planner. You just said it.
Oh yeah, because you're gonna make us stay home from church.
Oh yeah.
Oh yeah. Oh
I
yeah.
was talking to the hall about how. Oh yeah, because Tanner was saying I'm a sinner because I'm gonna have to take that with God when I'm going to church on Wednesday except study for.
We're all sinners, so we are just agreeing with God.
Okay, guys.
Wow.
What?
Oh god.
This is the more.
The ideal guy. Why did you have to play that? Equals NRT.
I have heard worse. I have heard worse.
You know which lesson this is?
This is 12.
The one that was due yesterday.
What percentage is that?
Okay. So you don't have the one before that done yet.
What? Which one?
10C.
I'm so
I thought that was the one
That's
I owed you.
Sally, do you have
I mean, I'm showing 2.
If I had food, I would give it.
Pull out your notebook outside.
Thank you.
It's possible I didn't write it in.
Kramer will let me.
So that's the one you just turned in.
Kramer.
Not
I
every
don't know, I've
class.
missed so many days.
I know.
I've only been here like twice.
There's some finishing.
No, you're
Just giving you time. I just wanted you to know.
Not like.
If you did it, please, yeah, show me.
No,
I
I
might
might have
have.
just ripped off my phone.
Usually I write them down right when you show me. But,
If I don't want the design, I'll do that.
Yes.
Yeah, then you can like keep going some white paint, like.
Why don't?
But I like the design. However feminine it is. I like it.
Feminine.
Yes, feminine.
Femininity?
Yes, feminine. It's a synonym for.
All right, we have the ideal gas law.
Okay.
Just for 20 minutes.
What if my mom texts me about food?
Please don't make me wait any longer.
What did I text them?
No.
Someone just texted me.
Hey, Gage, I'll take that too.
Oh.
40.
Popper is.
So, ideal gas law. A gas law whose behavior is perfectly predicted by the kinetic molecular theory. There are 6 postulates in the kinetic molecular theory. Do you know them?
No, what's happening?
Oh, particles don't bump into each other.
Okay.
They're very
That's
small.
one. They're very small.
Lots of distance between them.
Okay.
Constant rapid motion.
Constant rapid motion.
They're
Elastic collisions.
Okay, yep.
Average energy is temperature.
Basically, the speed of the particles is related to the temperature. Okay, if you were to, I think there's one more maybe we missed.
Particles do not interact with each other.
What did you say, Russ?
Easily compressible.
That's not in the kinetic molecular theory, but that is sorry.
They don't interact with each other or the
Okay.
walls and rest of the motion.
Now, so an ideal gas is one that is perfectly predicted by the kinetic molecular theory. However, I said when we talked about the kinetic molecular theory that there are some assumptions that are made. Here are the 2 assumptions that aren't always true. Assumption 1. I want to write this in.
Where do you want us to write this down?
I don't know.
Wow.
Wherever you can find it. Okay? The assumption, the first assumption that is made that's not always true. Okay? That is the first assumption, that gas particles are extremely small compared to the great distances between them. Who can tell me why this is an assumption and is not always the case?
What if it's compressed?
Ah.
Yeah.
Okay? So there are really two situations where this assumption doesn't work very well. The first is at high pressures. Because high pressures is going to do what?
Make it float.
Make them float, yeah.
Okay?
Yep.
And if you compress the gas, now is there great distances between them?
No.
And could we assume that a mole of any gas then occupies 22.4 liters?
Yes. We could assume that.
We could assume that, but it wouldn't be a good assumption. Because remember, the reason why we can use that 22.4 liters number is because we're assuming that there are such great distances between them that the actual volume of the particle itself doesn't take up any of the overall volume. Essentially, we're saying the gas particle has no volume because it's tiny compared to the great distances between them. But if you compress them, now do the volumes of the gas particles themselves become a little bit more important?
Well, then you're not STP, so it doesn't matter.
Sure. You're right. That's partly why we say it has to be at STP. Because STP is actually a relatively low pressure. But under really, really high pressures, you cannot make that assumption. There's another situation that would also result in having less distance between the gas particles. Anyone know what that would be?
Low
Electronegativity.
Good guess, but
temperature.
tell me why. What happens under low temperature?
And moving slower.
Okay, that's true. But how would that affect the great distances?
They're not rubbing together.
Don't we have a gas law that relates volume and temperature?
Oh, they
Whose law is that?
did. Charles.
Mr. Charles. Mr. Charles said that if you decrease the temperature, what happens to the volume? It goes down. It's a direct relationship. So if you slow down the particles, and it has something to do with how the pressure is impacted, but when you slow down the particles, what happens is you're going to decrease your volume. If you decrease your volume, can you assume this? AKA, could you assume that all gases, when you have 1 mole of it, is 22.4 liters? Can you assume that? Okay. But is it an okay approximation, Tanner?
No.
You can assume anything.
Yeah, that's right.
You can assume donkeys can fly, but that doesn't make it right.
Okay.
Well, you could assume it. Wait, you're saying you've always believed that donkeys can fly?
Why do they have tails?
What?
Number 2.
I'm just kidding.
Like a helicopter.
Wait, did you say a helicopter has a tail?
Oh, my
That's
slide.
helicopters have tails.
Okay, where's the fur? Where's the hair?
Hey,
They
I
have
like
tail. The tail of the helicopter comes out. It has the.
Alright. Okay, so, when, let me ask you this then. Shh, focus here. When could we assume that this is true? Under what conditions could we assume? STP, okay, that's one situation. But if high pressures makes us not able to, and low temperatures makes us not able
Low
to,
pressure and
could-
high temperature. Whoa.
okay?
Good
so what
job,
it's saying
Trinity.
is, wait, we've already got that. Is there anything in your notes that says anything about when you can always assume gas acts ideally? Does it say anything about that anywhere?
The ideal gas law.
Low molar mass, low pressure.
Alright, here's what I want you to put in. Maybe somewhere off.
Whoa.
What is
That
going
was
on?
a
What did the
good
marker do to you?
dodge. Yeah. Okay, so
Very good.
these are the conditions when a gas acts ideally,
Which doesn't always happen.
which doesn't always happen, right?
That's not a.
Under low pressure and high temperature. Those are the conditions where a gas acts ideally. What does that mean when I say a gas acts ideally? What has to be true for it to be an ideal gas? Look at the definition of the ideal gas. Come on. What? Predictable by,
Kinetic molecular.
okay? So if we're at low temperatures and high pressures, the kinetic molecular theory is pretty much spot on. But, like we said, there are some situations where it's not. Yes?
What would be considered high temperature?
Anything above STP would be fine.
-7 degrees.
Yeah. I don't know the exact cutoff when it becomes too important. I don't know. Right? Second situation, or second postulate that does not, that is an assumption that's not always true, and it's that, I'm going to abbreviate it, particles don't interact. I'm just falling apart. Remember some of that song before? Okay, so we make the assumption that when gas particles are flying around, they don't ever come into contact, and more importantly, they just don't interact at all. Which means that they move in a straight line always, even when they go by another particle that has a charge with it, they're not attracted to each other. And do you guys remember why most of the time that's a good enough approximation? Because they're moving so fast, yes. If they're moving so fast, even though there's maybe a charge attraction to each other, they go by each other so fast that it's considered to be basically negligible or have no effect. Okay? So what would cause it to actually not be negligible anymore, or to cause the attraction to actually have an effect? They're moving slowly. So, when are they moving slowly?
Low temperature.
Yes.
Low temperature. So again, what you're seeing is there are two postulates that most of the time are good assumptions, but under certain conditions, they're not great assumptions.
Always read the terms and conditions.
Always read the terms and conditions. I just love all those commercials like, you can overcome this disease. And here are the side effects, and it lists like 500 side effects. It's like, you will feel awful for the rest of your life and could potentially die.
It's like could heal the flu. Or it's like heals the flu, and then on side effects, could cause stage 4 lung cancer.
That's funny. I love it.
When's our next?
I love those cancers.
What was your favorite Super Bowl commercial?
I don't know.
Dirty
I think they get-
Dancing.
That was-
Absolutely.
I think they get lamer and lamer every year.
They do.
The avocado one was
The
pretty good.
avocados from Mexico one was
But
good.
I like.
I thought that was so.
The Tide.
I don't know. I don't like dumb commercials. I like witty commercials.
The best
I
one
like
was
the
the
Alexa.
Ram truck commercial with the Vikings going to play.
I hated that one because I'm a Vikings fan.
I mean, yeah, but I could say, but I thought it was kind of.
It was witty. It was clever.
It was
Yeah.
witty.
I agree with that. I like witty,
That's
clever
not-
commercials. Like I thought the Tide one where it was like the first Tide one where they talked about how isn't every commercial really a Tide commercial. I thought that was pretty witty. You guys
Yeah,
probably.
because everybody's selling iPods. Yeah.
Because it mocked like all like the beer commercials and the other. It's like, isn't it just the Tide?
What about the Iowa commercial?
Budweiser
The
has a
Super
drinking
Bowl one.
commercial.
What about the what?
The Iowa commercial. The
Oh.
Super Bowl one.
Senate.
Wait,
The one with the bull?
Yeah.
Yeah.
Oh.
they had the commercial about the when they stopped.
Alright,
producing
anyways,
economy
let's
of
do
the
this.
water.
So here is your ideal gas law. You're going to want to put this in as your last law into your law table, which may remind you will be on your test, and you will have to put it in.
Maybe.
Yes, that would have been funny.
That,
Okay.
no, that was
So just telling you guys, I'm not giving you anything for this test. No equations.
Wow.
No 1 atmosphere equals 760 equals 760
We should
equals
take this one.
14.7.
Did I miss one?
What?
We should take this Monday.
Well, I mean, you can. You've been gone a lot.
Can I?
Nice.
Okay.
Sure, but you can get your homework.
Morgan's taking it Thursday, you can too.
I've been here like one day this chapter. I don't know what's happening.
Your name would be the ideal gas law. Your equation would be PV equals nRT, or PV equals nRT.
You guys sucked at singing. You need a new microphone because you cannot.
Yeah, it sounds like a 4-year-old kid, but. Alright, then there is a constant, and it is R, or the universal gas constant. Let me show you where this comes from. Let me show you where we get this number.
This was a mistake, Mr. Kramer. You were a mistake. That was a mistake.
Brevin.
I need those milk bags, man.
Oh.
Okay.
Wow.
Come on, let me, guys, I want to show you where this comes from.
Oh.
Okay? What is STP volume?
22.
22 before.
Oh, I tried.
Good job.
What is standard pressure?
1.
What is standard moles?
1.
What is standard temperature?
2.
Alright, can someone solve that?
I got it. .0821.
You're right. You are right.
Fry.
So what this does?
Shut up.
Now listen.
Nice for color.
Listen. What this does is it relates all of the units to each other in a nice handy dandy constant. Now, listen to me. When doing the gas law, ideal gas law, you must be in these units. So if you're in torr, or they gave you torr, you must convert to atmospheres. Here's the alternative. I can make you memorize 100 different constants with 100 different units. Okay. How about we just know one constant,
Would that
and
be
then
back?
you don't want that. Trust me. Okay. That's like me saying, here, you have a take-home test. Like you would say no. Say no to that every time.
We will.
Why?
Because take-home tests are infinitely more difficult.
Yeah, you have resources.
No, but you're not gonna find
Trust
answers
me.
on Google.
We did. They made that mistake in college. We're like, yeah, let's have a take-home test. It took me 10 hours.
Oh, you didn't have
Why?
We had Google. You don't think a teacher's gonna be smart and give you a problem that you can't Google the answer to?
There's probably you can't Google here.
Yeah, ones that you make up on your own.
Yes, I'm not going to college.
Can't you put it in like a text?
Well, you could if
What
you
is
don't
wrong?
want
You're
to.
gonna be a successful.
Now,
I don't want to.
so did everybody get the ideal gas law for the name? Okay, your constant is R, and your equation is PV equals nRT. Very important that you get the correct units, and that's why these units are right there.
What is our?
The universal gas constant is 0.0821. All right, let's solve this problem. Okay, we'll start easy, we'll get a little bit more difficult. Now, the way to know the difference between our typical gas laws, where you had P1, V1 equals P2, V2, and your ideal gas law, is you're never going to have second conditions. Does that make sense? There's no 1 and 2, which is really nice because of this gas law, you don't have to have you don't have to have like a final condition and just compare. You can take and use this gas law without knowing any of the final things. So, how many moles, what is that, of a gas are present at a, what?
4 liter.
Volume of 2.4 liters at a pressure of
1.525 ATM. And T is 200. 300. Dang it. I was going to add it up.
and we know our R. Okay, now do our units match up with what our R units say they should be? I'm just going to refrain from writing the R units because it takes a long time.
273 plus. No, we're in it. We're in it.
Okay, what are we solving for?
And
And
Okay, N equals PV over,
P even R.
okay, plug in and solve. And you should see that your unit should cancel out with your R values correctly to give you the unit that you desired for moles.
I just call this the pervert law.
Where's the N?
And where's the E?
Pervert.
Pervert. I don't know.
Oh.
Anyways, whatever. How about you solve, because we do have a couple more problems to get to. I see a couple people working. I see a couple people not working.
My calculator.
I am doing it in my head.
What the world?
Actually,
Or was that the catch?
Why are we throwing it at me?
So you can get, well, then pull it out.
What?
Well,
I love this calculator.
Holy cow.
I love you.
Okay,
Boy,
let's
it's so
do
omnipotent.
P.
What? Omnipotent? How?
It is called omnipotent.
Wow. Okay.
What did you
I'm assuming you're close to solving. You've had enough time. I actually solved it for you.
0.0.
Like you just gotta plug it into your calculator. Natalie, what'd you get? Natalie,
10,000. Oh.
0.12.
0.12 moles.
What the heck?
10,000.
10,900.
I was only 10,000 off, guys.
Bro. So you need double parentheses.
I
Can't see the board.
That's why you use the handy dandy calculator right here. $15 at Target.
I would never use anything other than that.
I smell the
$100
gender.
at Target.
That's ridiculous. You need $100 calculator.
85
that
at
for
Walmart.
You need it for math class.
Yeah, but does that actually isn't that calculator pretty much do everything for you?
Yeah.
Yes,
So
it
you
will.
don't
Well, yeah, but you
have
would
No.
have
You can program in equations.
Well, I
to me
still
that's
have
what
to
we
think
don't
about
know
it. I
how.
don't know how to use it.
Do you know what log is?
You do a log-based
I don't know.
anything.
Logarithm?
What does that mean?
Base
How
10?
do you do that with your mind?
Well, you know factors of 10.
You know what?
What if it's not?
We didn't go to college for this kind of
Or
stuff,
log
so-
12 or log 130.
Name all of the factors of 130 right now.
I know. Okay, what do you guys get?
I don't.
Sorry.
Natalie said.
0.12 moles.
Yeah.
So 2 sig figs is what we should do here.
Why is your one so curved?
Oh, nice.
All right. Let me see here.
I did the next one. That's I was like,
Let's
why?
not do this one. Let's do.
Not that one.
Oh
Dang it.
shoot, is this in our thing?
I don't have any good problems here.
Where we have to
Yeah.
convert.
Alright, just gonna give you a little heads up. Could they give you mass and ask you to use the ideal gas law?
No.
I mean, they could, but.
What would you do if they gave you the mass?
No.
Convert it to
Volume.
nope. Yeah, volume. No.
Moles.
Oh.
Yeah! How would you convert mass to moles?
Boyfriend. Girlfriend.
No, that's the stoichiometry chart.
Well,
Wow.
could you convert mass to moles and use
Using the molar mass.
Yeah.
Yes. He's right.
I figured that out. No.
What's that?
Alright, so there's a variety of things they can do. If they don't give you moles, but they give you mass and they tell you what the mass is of, you can use the molar mass in the periodic table to be able to convert to
What
moles.
if you need to make it to volume?
Yeah, if they gave you let's see, they gave you milliliters. Could you convert that to liters?
No. Times 1,000.
Okay, if they gave you
Only 10,000 off.
PSI, if they gave you PSI, could you solve for that?
How do you go from million?
Yeah.
That would be harder than drop. Hey, 14.7.
Yeah.
Never get that one wrong again.
True. All right, so is this the second problem?
Yeah.
Okay, are we solving for n again? Let's solve for volume here. Okay? This is actually, again, none of the math in this chapter is difficult algebraically. The most difficult thing is probably knowing which gas law to use. Okay? Remembering some of them. But from a math standpoint, from an algebraic standpoint, I think you should have seen at this point that nothing in chemistry at this point has been more difficult than Algebra 1.
Yeah, all of it.
Is there gonna be math that gets difficult?
There will be in the dreaded equilibrium chapter, there will be cubed root. But
Cubed
that's
root.
still like
Root. Cubed root.
Be nice or lower.
What?
so. We got moles, 0.323. We've got temperature, 265. We got pressure,
The next one.
0.9 ATM. I just don't like that I did not write a problem in here that
Why do we say they?
I thought we were doing
Well, technically I don't just write the problem usually. I usually find it out of a book. Usually, not always. Now, could I make up a problem? Absolutely. This wouldn't be that hard to make up random numbers, but then I have to worry about wording it in a way that makes sense, and I don't. do English very well. Okay, so now you're solving for B.
Yeah.
8 pounds, 6 pounds.
You guys got the answer to the last one?
Oh, yeah.
Little
I got
photographic
7.8.
memory doing you good.
7.8 is what I got.
Any questions? Here's what I will say about the ideal gas law. Units are important.
Are they?
Well, they're important in everything. But in these specific types of problems, you have to have the units that agree with your R value. Otherwise, you've got to know all the other R values that go with all the other units.
Honestly, I haven't cared about units till like last year.
Of course.
Is someone in that car?
That's because that's the first time you did physical science, I'm assuming.
To be successful in science, units are very important.
What's the answer?
The answer is 7.81.
Can you leave that? Natalie, can I have this paper?
Can you use this calculator?
Yeah, homework guys, sorry.
Have a great ride.
Alright, and then if you guys could get out of here as